since we were asked to make some relatively accurate power measurements, we're going to need to calibrate some of our probes and make sure that we are taking care of calibration and deskew so we can measure switching losses relatively accurately. So, since we don't have any fancy tech VPI stuff here, we're working with some fairly crude probes, but they will do the job. This is basically a homemade high-frequency current probe that we use here. Measures up to about 500 amps. So we're going to do a quick calibration check on it and set the scope up to measure current. So the first thing we need to know, since this is not a calibrated probe, is we need to know what the conversion from current to voltage is, since we're using a voltage input on our oscilloscope to measure the output. So we're going to use a calibrated power supply in conjunction with a dynamic load to measure this probe sensitivity. So what we'll do is we'll just pass one of the outputs from the supply through the probe and connect it to the load, and we'll turn on the power supply's output. And what we'll do is we'll watch what the voltage measurement on the scope is. So we see the soft ramp up of the load. Right now it's configured for a load of about 6 amps. And our actual measured current on a calibrated power supply is about 5.990. Let's see if we can get that a little better. Okay. And here we see our measurement on the scope. And this is in the DC domain, of course. This current sensor is good up to the range that we're using it for these power supplies, which is around just over 100 kilohertz. So we're going to make a quick measurement of our voltage here. And here we see with a measured current of 6.03 amps, we're measuring about 59.2 millivolts. So to do that conversion, we need to know, to calibrate the scope, how many millivolts per amp this probe is generating. So we'll take our 59.2 and divide that by 6.013, which is about now. And we end up with 9.845 millivolts per amp. So what we'll do is we'll go into the vertical menu, go to More, tell this we want to use this probe as a voltage probe, but to measure current. And we have to tell it how many millivolts per amp this probe sensitivity is, or how many amps per volt. And we can express that here to say this probe is roughly about our two steps are either 101 amps per volt or 100. So we're closest to 9.845 is much closer to 10 millivolts per amp than it is, we could leave it. It's about halfway in between. So let's see what we can get here. Let's see how much granularity we get with this control. About 101 amps per volt is pretty close. So once we put that in as our calibration, now if we look, our measurements are made in amps. So here it's about 2.02 amps per division. And if we look at our delta measurement now, it's about 5.98 amps versus about 6.0. Let's see if we get that a little bit closer. That's pretty darn close. So we're saying about 6.038 amps against 6.038 amps. So that puts us pretty darn close to calibrated. So we're dealing with about 2.04 amps per division with this probe. And we can check the linearity pretty easily. What we'll do is we'll reduce the current that the load's presenting to right around 2 amps. And we'll go back to our scope and take a measurement here. And here you can see the readout. That's close enough for me. So that's basically how you calibrate a cheap probe for current, to measure current on an oscilloscope.